In this video, I will derive the formula for the fringe width. What is the fringe width? The distance between two consecutive bright or dark fringes, dark fringe is called fringe width. Fringe width represented by beta. The distance between two consecutive bright or dark fringes is called fringe width. Now, I will derive the formula for the fringe width. For this, consider these two sources S1, S2, and this is your screen in Young's experiment at which fringes are to be observed. Let the distance between these two sources is D. Now, this is your center. Let the distance of S1, S2 from the screen is capital D. Is capital D. I want to observe the fringe at this point P, which is at a distance x from the central fringe. Now, this ray goes from S1 and this ray goes at P from S2. This is S1P, S2P, this is your S1P. Now I have to calculate the path difference. For calculating the path difference, let now, sorry, for this no requirement for. Now, this was d1 by 2, so the distance that will be x minus d by 2. And for this, there is this distance will become x plus d by 2. I name this S2A, S1A, and that is B. Now I want to calculate the path difference. What is the path difference in the rays going at P from S1 and S2? That is equal to path difference. Path difference. That is equal to S2P minus S1P. Now S1P you can calculate with the help of the right angle triangle S1p equal to d square plus this is also d, and the x minus d by 2 to the whole square, minus S1p x plus d, that is the total distance is x plus d by 2. Or the second one, that is d square plus x minus d by 2 to the whole square. This will be the part difference between the rays reaching from S to P, that is S to P minus S1P. S to P, this is square plus this square to the root will be S to P, and similarly the S1P equal to d square plus x minus d by 2 the whole square. Now I calculate it mathematically. S1p, S2p minus S1p equal to, take d square common, outside it will work as d, and it can be written as 1 plus x plus d by 2 upon d to the whole square. Similarly, minus d root 1 plus x minus d by 2 upon d to the whole square. I take common d, and root means power half, 1 plus x plus d by 2 upon d to the power half, minus 1 plus x minus d by 2 upon d to the power half. That is. Now, d equal to, by the binomial theorem, we know 1 plus x to the power n nearly equal to 1 plus nx. Now I multiply this power here by the help of binomial theorem. You will get 1 by 2b x plus b by 2 to the whole square also. Whole square also. Whole square. 1 by 2 d to the whole square minus 1, that will be 1 by 2 x minus d by 2 upon d to the whole square. Now, path difference delta x equal to d minus 1 is cancelled by minus 1, d and half take you common, you will get x plus d upon d to the whole square minus x minus d, d by 2, d by 2, d by 2 to the whole square and d by 2 upon d to the whole square. Now, take d again common, delta x d by 2 upon 2d square, you will get x plus d by 2 the whole square minus x minus d by 2 to the whole square. Now, d is cancelled by d, delta x equal to 1 by 2, solve the whole square, x square plus d square by 4 plus twice x d upon 2. Now this is minus x square plus minus d square by 4 plus 2x d by 2. This is cancelled by this. X square is cancelled by this. You get delta x path difference equal to 1 by 2. This is cancelled by this. This is cancelled by this. 1 and 1, 2 x d by, okay, sorry, that is 2d upon d. This is 2 is cancelled by 2. We get delta x equal to x d upon d. I got the path difference equal to delta x equal to x d by d. So here that is d. Now I change this path difference into phase difference. Remember one formula, phase difference equal to path 2 pi by lambda into path difference. 2 pi by lambda into path difference is x d upon d. This is the phase difference. Now for bright fringe, phase difference delta phi should be equal to 2m pi. Now put the value of phase difference, that is was 2 pi by lambda into x d upon capital D equal to 2m pi. 2m pi, pi is cancelled, 2m pi is cancelled, 2m pi. So I can write in general xm equal to m, that will go here, d lambda upon here d. This is the distance of mth bright fringe from the central fringe. Now the distance of xm plus 1 at fringe equal to in place of m plus 1 d lambda upon d. Now the distance, the fringe width, that is the distance between two consecutive fringes, that is bright fringes. Now put the value m plus 1 d lambda upon d minus m d lambda upon d. You will get beta equal to m d lambda is cancelled, only we get d lambda upon d. This is the formula for the fringe width for bright fringe. Now I will take the case of dark fringe. For dark fringe, you know the phase difference delta phi should be 2m plus 1 pi by pi. And I also can write it as minus 1 m to the value 1, 2, 3, like this. Now, I have got the phase difference before, that was xd 2 pi by lambda xd by d equal to 2m minus 1 pi. Pi is cancelled by pi, and then again xm d upon d lambda equal to, divided by 2, you will get m minus half. Now xm equal to m minus half d lambda upon d. Next, for the next dark fringe equal to m plus 1 minus half d lambda upon d, that equal to xm plus 1 equal to m plus half d lambda upon d. Now, the fringe width for the dark fringe x, that is beta, equal to again xm plus 1 minus xm. Beta equal to xm plus 1 m plus half d lambda upon d minus m minus half d lambda upon d. Beta equal to minus minus plus, that is cancelled, or we get d lambda upon d. You see here that fringe width for dark and bright fringe is same, and now it is generally called that fringe width equal to d lambda upon d. This is the formula for the fringe width. Okay.